Hi, my name is David Cadena, and this is the program for Exercise 6. Let's right-click in the 2D array and refresh the package, and would you look at that? Both files file.in and results.out have been created. In the file.in, we have the input text, and the rest is Rust and Stardust. Over at the results.out file, we have this odd-looking sentence as the output from the program. The program consists of 4 parts. The first part creates the input file printing, and the rest is Rust and Stardust inside the input file file.in. The second part creates the 2D array of chars and fills each position with asterisks using a nested loop. I'll explain why later. The third part consists of the while loop printing every character from the file.in into the 2D array. And finally, the fourth part prints the array elements column by column into the output file. Okay, let's dive into the code for each part. For the first part, it includes pretty much what has been done in the past 2 exercises. But just as a mere summary, we use the file output stream in a print writer to create the file.in with the text. And then of course, we close pw, the print writer, and fos, the file output stream, to save the file. The second part declares the int constants, rows and columns, and assigns them to 4 and 8. These 2 variables represent the size of the array going to be declared. Then, an array of chars called table is created with the dimensions, rows, and columns. Here, we declare the int variables I to read through each row and j to read through each column after each row is read. Lastly, a nested for loop is used to print asterisks in each position of the array. The third part is the heart of the program. This is how I approach the problem. To fill the array with the input text, I rely on an index that points to a character of the text and indices to know the position of the array to write the character on. To do this, I use I and j once again to go through the array. I also declare the int variable k to represent the index of the current char of the text that is assigned to the current position in the array. To access the text, we create a string s that holds the whole input text, getting it with the next line method of the scanner. Here we create a while loop to print out the sentence in the array. While the current index of the string is less than the length of the string, meaning we haven't gone through all the characters in the string, and the current row is less than or equal to the size of the rows in the 2D array -1, meaning we haven't gone out of bounds surpassing the last row, the loop keeps executing. We have the char c reading each index of the string. Then here we are assigning each character of the input into the 2D array table in the position I, j. In these next lines, we have 2 if statements. The first adds 1 to the column's index j if the current row is even. Otherwise, it will subtract 1. In both cases, when j goes out of bounds, the current row is increased by 1, and the current column is resetted to the first column or last column, depending if it is even or odd. Lastly, we close a scanner and file input stream from that I created from the file.in. Lastly, the fourth part consists of the file output stream to create the results.out file and the print writer to print the results to the output file. Then we have your nested while loop to print the characters of the file column by column into the output file. We finally finish off by closing the print writer and the file output stream. The interesting part about this is that we first iterated through the columns and then through the rows instead of the other way around. One of the exercise requirements demanded for asterisks to fill in any leftover spaces, if any, after the printing of the sentence. However, this seemed complicated and difficult. So instead of filling in any spaces with asterisks after printing the statement, I decided to first fill in the whole table with asterisks and then fill in the statements on top of the asterisks. Thank you for watching.